Hello and welcome everyone on Data Science Project Bank platform. And today we are going to do a complete machine learning project focused on predicting credit card leads using a bank customer data. So in this project, we will cover everything from defining a business problem to deploying a predictive model that can be used in the real world application. So let's dive in. Imagine you are working for a bank that wants to identify potential customers who are likely to show interest in a new credit card offer. So the goal is to create a predictive model that can help the bank target these customers more effectively, saving time and resources. So in this project, we will do each and everything from step by step, and you will learn how we can build the end-to-end data science machine learning project in fintech domain. You can also say in banking domain, either BFSI domain or finance domain. This project cover all these domains together here. So let's go and do this project step by step. So the very first step is the formulating the business problem. After understanding the objective of this problem or this project, you need to identify or you need to formulate the business problem. So let's go and understand the business problem here. Here, bank need to optimize their marketing strategy, focusing on the customer who are likely to be a future customer for the credit card, right? Who likely to show their interest to get the credit card. So bank want to predict those customers using a machine learning model. Okay, so by leveraging the historical customer data, the goal is to build a machine learning model that can accurately predict whether a given customer will respond positively to the offers or not. So this will enable bank to improve their marketing or targeting efficiency or strategy. Using this predictions, they can improve their marketing strategy. They can increase the conversion rate, because when they enhance the conversion rate of credit card offers, they will get more customer, right? And last but not least, optimize marketing cost, because when they do this exercise to find the lead of credit card customer, they need to put some cost there, right? So to reduce marketing costs by minimizing efforts on customers with the low probability of responding, this will be the another thing we can focus here in this business problem. So hope you got this business problem. And now we can go and understand the data. So the bank given or bank share their historical data with us, and we will understand what are the different kind of features and column available in this data. So here you can see the first column is customer identity, the unique identity of each customer. The second one is gender. Gender could be male and female. Monthly income, the monthly income of the customer. Age, region code, the geographic region code. Occupation, so it's a type of occupation. It could be salary, self-employed, business, or a student. Okay, it means it's a categorical feature. And then credit score, the customer credit score, right? It's a score given by uh, the rating agency for each customer based on their historical performance of the transaction with the banking systems. And then loan status, it means whether the customer has any active loan or not. Okay. Then existing credit cards. Okay, it means the number of credit card the customer already has so far. Then average account balance. Okay, it means the average balance maintained by the customer in their account. Then account category. Okay, we know, right? The bank has a different categories for different customers. So it's a categorization based on account balance or other uh, services included in that particular bank account. It could be high, low, medium, privilege like that. And tenure with the bank, the number of years the customer has been with the bank, and then lead outcomes, whether the customer showed interest in a credit card offers or not. It means it's a lead. And this is our target column or target feature, which we want to predict based on these other columns or other features. Right. So let's go and understand the goal of this project now again. So already we have discussed this. The goal is to develop a machine learning model to predict the lead outcome. It means the future credit card customer based on a provided features, enabling the bank to efficiently or effectively identify and target customer who are most likely to be interested in the credit card offer in future. So hope you all understand the first step of this project, that is understanding the business problem. Or I can say, before starting the business problem, data science or data analyst team has to identify the business problem or the opportunity within the business so that they can align with the expectation of the client, right? Once we understood this business problem, then we start setting up the environment or the IDE. Some people like to work in Jupyter Notebooks, some like to work in Google Colab, some like to work in their another uh, development environment like VS Code or PyCharm or other platform, right? There are n number of platform we can use to write the code and write the program. So today we are using the Kaggle platform itself here. And you can see here, I have set up the environment for doing a work here in Kaggle itself, right? It's very easy. So you can understand that, right? I have used this operating system library uh, to define the data set. You can see the data set is already saved here, the bank customer data for credit card lead predictions. So I use this particular code to read my or to define the path of my data set. And yeah, so this is for setting up the environment. And once we set the environment, then we start with the project. So the very first step of our project is to import the necessary libraries. So I hope you people are already aware with these library, the pandas library for data frame, numpy library for also managing the any data, and matplotlib for data visualization. Cbon is also for data visualization. sklearn library we use for machine learning stuff, uh, right? So these all things we do for machine learning stuff. So we here import the library. So let me run this particular cell, execute this cell, and see how it works. So I run this cell, and there we go. These all libraries are imported here. And now we go with the second step. The second step of any data science project is gathering and exploring the data. So now we gather and we load the data from our Kaggle library itself. So now I'm going to execute this cell and we see There we go. My data is loaded here. And now we go and check the structure of our data. So you can see here, this data has around 10 lakh 5,000 of rows and 13 columns. Let's go and explore data in a tabular form. So we use this command data.head. And once we run this line of code, it gives the first 5 rows of our data set. So here you can see the ID, the customer IDs are there, unique ID, gender, monthly income, age, region, occupation, credit score, loan status. So it means loan status has some value, the blank values, existing customer credit cards, average account, average count category, tenor with the bank, and lead outcomes in a binary form, yes or no. So this is our target column, right? Lead outcome is our target column. And this is the target column has been already labeled with the yes or no. It's a classification model. You know, there are so there are many types of supervised learning, regression, classification, like that. So we can say this particular project is related to classification supervised machine learning model. And we will do this project for predicting this lead outcome. So far, so good. Hope you are with me here. If you have any question, please post your question in a comment box and we will answer your all the question later. Now I'm going to print data information, the data set information. So here you can see this is the pandas data frame and range from 0 to 104 triple line. And here you can see this is the columns. This is the way it shows whether your data has a null value or not. So you can see ID has almost 0 null values, but this loan status only have few data with null values. Okay. And here you can see the data type. There are 2 data types. One is integer. So 7 feature are integer format, data format, and remaining are object data format. So let's go and do the next step our project, that is data cleaning. So, you know, it's depend on data cleaning is completely depend on the nature of the project and your understanding in the business and your experience in data world, because there is no such way to handle the data cleaning activity. Yeah, there are a function we use to do the data cleaning, but the approach to clean the data is definitely vary to person. And here, as you know, this is the banking data. So, and bank always want to make a 99% uh, quality. Bank always want to keep the 99 or 100% quality data with them because it's a financial transaction data and it always be in a quality manner, right? So I don't think so. We need to do a lot of data cleaning work here with this data. So let's go and check how many null values are there. So only loan status data, and that is our target column, which keep this 12,489 data points as a blank data. So because this is our target variable and we can't replace this target variable, or we can't uh, manipulate, or we can't treat this particular loan status data without understanding whether any, my bad, I'm sorry. This is not our target variable. It's a column which shows whether particular customer has another credit product or any credit service or not. But again, without understanding whether any particular candidate have other credit or loan product, we can't treat this with the mean, with the mode or other treatment uh, option. So we just go and drop this particular column here. Okay, and let's check again whether we have other. Okay, so we don't have other null values. So we will go and do our next step of this project. So the next step is exploration the data. So let's go and explore the data one by one. You can see this dot describe function describe your data in this manner where you can see mean, your min, standard deviation, max, and your distribution of your data with 25%, 50%, and 75%. And you can see the summary of this data set, only those column which has a integer data type, right? So using this, we can understand that, like, let's suppose we see the monthly income. So the monthly income of the customer would be in around 40,820 to 2,10,500. Okay. And majority of customer are lying within a 75% of bracket. Age, you can see here the age of the customer lie between 14 to 85. Okay, the maximum age is 85. Okay, credit score. So the credit score would be in 179 to 767. Okay, so after understanding this particular summary of your product, your data, you can get at least high level of overview of your data. Okay, so now go and do the exploration of your data using some data visualizations, graphs and charts. So here we use Seaborn library to do the data visualization. But you can see here, I have defined three functions. I have created three functions. The first one is for plot distribution, second one for box plot, and the third one is for bar plot. So I have already created these three functions which help me to build these three types of chart. So you can see I have created these three functions to build these three types of plots or chart: the distribution chart, the box plot, and the bar chart, right? So let me go and execute this cell. Okay, let me execute this cell. Running. Cool. So it runs. So after running this cell, now let's explore each column one by one and understand the insight of that particular column. So first column is gender. Let me go and run this cell. You can see here the male candidate or the male customer are more in comparison to female. And if we see the distribution of credit card, oh, sorry, yeah. The credit card distribution based on these two categories, the gender category, male and female, we can say male candidate has less approval of the credit card And same with the female. Okay, there is no such difference, but we can say they are slightly equally distributed the credit card for both gender category. So using these data visualizations or chart, we understand the nature of feature data. It means if you want to understand why we do this exploratory data analysis. So the reason of doing exploratory data analysis is we try to understand the nature of each and every column so that we can think about the uh, data analysis solution or machine learning solution based on this statistical description of the data, right? So now I'm just going fast to save some time. I just run another columns and show you how using this distribution function, we understand the distribution of monthly income based on different bins, and we understand income of each and every customer. And here you can see the monthly income of the customer and the distribution of credit cards based on the income. You can see the people who has more income, the chances is likely more they get the offer of credit card. Yeah. And now we go and run the age and see. You can see here the age is live will between 40 to 60, but the majority of people are between around 20 to 30. Okay. And you can see here within 30 to 50, people has less chances to get the offer. We will see the reason later, but here you can see the people who, yes, they are live within 35 to 55. Okay. Let's go and check another feature. Fast, reason, okay, slightly, okay, reason, and then occupation. Based on occupation, you can see the self-employed are more in the data set than salary, and then other entrepreneurs are very less. But if we see self-employed has equal opportunity to get the offers, but for salary people, oh, here you can see for salary people, less chances they get the credit card and more chances they reject it. Okay, for others equally, but for self-employed, there are equal distribution of credit card. Let's go and check credit score. So using these graph and chart, we just wanted to understand the nature of the feature, as I said earlier. For credit card score, for yes, yeah, it's obvious. Who has higher credit card score, they get the offer. So it's a directly related with the offering of credit card, and it's a by nature, right? We all know if you have a high credit card score, you will get more offers for the credit product. So let's go and check the loan status. Okay, no are around 60,000 and 30,000 for yes. So we can say it's an imbalanced kind of data. Okay, for no loan status, loan status, who has already loan, chances are more bank will not offer the credit card. But if you have no loan product, then chances is are higher, you will get the credit card offers. Okay, so based on these things, we understood the nature of all features. And now I'm just running these remaining cell, and you can understand based on these distribution chart, box plot, and others, we will understand the nature of the theta, different categories. So the X1 category is high in the data. It means the primary account, we can say. The privileged accounts are very less. Okay. And tenor, let's see the tenor of the data. Tenor of the customer, majority of customer are with 5 years with the bank. Okay. Yeah, it's also obvious. If you have long relationship with the bank will definitely offer you the credit product based on your loyalty with the bank. Okay, lead outcomes. So this is our target variable. You can see majority of people lying in no, less people are in yes. Area. Okay, so based on these outcome, we understood all the dependent and independent variable. And once you are able to understand all the insight available within these columns and features, we will go with the next step. So let's go with the next step. The next step is data pre-processing. So in this process, we will pre-process this data for machine learning model, because we know machine will learn, or machine will take the numerical data only. It will not take the categorical data. So we need to treat, or we need to convert this categorical feature into the numerical value so that we can insert, or we can input this data to the machine, right? So here we define the features or the column as a categorical column, because these column have a categorical data. And then we use this label encoder library. This label encoder function transform our categorical data into the labels. Label means if your data have three category, 1 to 3, it will convert 1 to 3. If your data have 4 category, it will label your categories based on numerical labels, right? So let me go and run this, execute this cell, and let's see. So yeah, it converts your categorical data into numerical data. And let's see. Here you can see your data is converted in numerical form. Your data has converted. Okay. So you can see category 0, 1, 2, your occupation 1, 2, 3, 4. Okay. Your outcome variable also converted 0 and 1 because it was it is a binary type of data. So once we have pre-processed our data, the next step is feature selection and feature engineering. So let's go simply. We drop our output variable and define this data as a target variable, and remaining column we use as a X variable, right? So we just separated our data as a dependent and independent variable, and let's run this. So this is the feature separation. Here we separate your all independent features which help to find the target variable, right? So once we do that, the next step is inserting this data for training our model. So we build the model, we train the model in this particular step. right? So here you can see we have already imported this libraries earlier, but for safer side, I am importing again. And then we split the data for X-train, X-test, Y-train, Y-test. And here you can see I use this particular function, train test split. And here we give our dependent all features, all independent features and target feature, and then divide this train and test data uh, in this ratio, 30% data and 70% data and random state, so that when we run this model again, it will give the same data every time, right? So now here I go and initiate the model. These are the model, random forest, classifier, logistic regression, support vector classification. So there are so many classification model you can use, but for this particular session, I'm just using these three classification model. And now we go and fit this model to the training data so that we can train our model. So let's go and execute this particular cell. I executed, and you can see kernel is running. And yep, random forest model trained, logistic model trained, and now it's training support vector classifier. So let's wait and see. It will take few minutes to train all the models. And meanwhile, I'm going to explain you the next cell. In the next cell, after training these three models, we will print the classification report, the performance report. So for this, uh, we have built this function to evaluate the performance of the model based on different performance metrics. So here you can see we will give the models, we will give the text data so that this model will predict the future outcomes. And based on that, we will check the accuracy with our model prediction and the test data. So using our training data, we trained our model, and using the test data, we just check the performance of our model, right? So here you can see this is the another kind of performance matrix, that is confusion matrix. In the confusion matrix, we see what are the different kind of accurate data points model predicted, what are the different uh, data point he didn't predict, and likewise you can see the classification report. In the classification report, we will check the accuracy of the model, precision of the model, recall, and another metrics we will see. So let's see. Yeah. So our support vector classification model is already trained. And now I'm going to execute this cell and see the performance report of each and every model. So here you can see the first model is random forest classifier, and it's giving a wonderful accuracy, 99, like 100% of accuracy. And it's just predicting few data points incorrectly, and remaining data points it predicting very well. And let's see the another report, logistic regression, slightly giving low performance, but not bad. And what about the supervised mush? Oh, this support vector classification. Okay, so logistic regression and support vector classification both are giving kind of similar accuracy. But for classification model, we should focus on the F1 score instead of the model accuracy, right? So here you can see it giving good F1 score. SVM is giving good F1 score in comparison to logistic regression. So cool. So here you can see the performance of the model. And based on this performance, we will go and do some hyperparameter because we know our random forest model is giving good performance. So we will just hyper tune the parameters of random forest. I'll here mention the estimators. So we will go with the 100 and 200. Let's increase the depth of our random forest model and let's define the minimum split to between 2 to 5 range. And based on these parameter, we will do the hyperparameter parameter tuning of this model. And here you can see we will use the grid search CV, the cross validation. So based on this, we will see the performance of our hyperparameter tuning model. It will take a minute. Let's wait for a couple of seconds. Okay. Meanwhile, we will discuss the next step. In the next step, once our model will get hyperparameter tuned, once our model get tuned, and we will check the evaluation report for this random forest classifier model, and then we will go and interpret our model. So I think there are many steps, 1, 2, 3, 3 steps are remaining. Once it's done, then we go and check the model performance, the tuned model performance. Okay, so I will request you guys, please stay till end because at the end of this particular session, I will tell you the most important thing which people never teach you, because you will see when people do different certification from different institution, they will learn all the skills, but the most important skill they will not learn, they, because most of the certification doesn't cover that. So here I will tell you how to deploy the model in production environment. And that is our, I think, last step. And I will show you how you can deploy your model in production environment and how you can do the prediction based on new data set, right? So just be with me here. Why it's taking too much time? Okay, it's done. So let's go and check the performance of our model. Here we go. It's great. It improved slightly and it's giving around 99.99% of accuracy. And you can see our model performance has already improved. Now we go and interpret the performance of model. So here you can see we have deleted the credit card score because credit card score is directly related to the predicting or offering of customer credit card. So we have just dropped that particular feature, but remaining feature are already putting there. And you can see the trainer with bank is the feature, the topmost feature, which are contributing more. Let's go and check and make this graph. And on the basis of that, we will see It means the tenor with bank is the most important feature for the model, then monthly income, then existing credit card, then category, then age. So you can see these are the parameters which are playing vital and important role to driving or predicting the outcome of that particular model. So that's it for building the model so far. And now we are going to do the most important thing, that is the deployment of any machine learning model. In the industry, majority of people know how to build a model, but less people know how to deploy the model in production environment. So here you can learn how to deploy the model in production environment. So here we use the joblib library to save the model and to load the model. So here you can see we import the joblib and then save the best performing model by the name of this credit card lead prediction model dot pickle file. And then we load this particular model as a loaded model variable using joblib dot load function. So let's go and run this cell. Okay, execute it. And now we are going to see how we can use this deployed model. Yeah, our model is already deployed. Using this particular cell, we have deployed our model. And now we are going to use this deployed model to predict new data point. So I'm going to prepare data set. This is the data I'm created. Let's suppose this is our new data. And let's check the new data. This is our new data. Okay. So now we give this particular data point or this data to predict whether our model is offering or predicting the lead for this credit card or not. So let me go and do this. So for prediction, we use this model.predict function and give the new data set. And based on this, it will get predict. So let's go. And we need to write this function or this line of code because our model will predict this in yes or no. And then we convert is our model will predict is 0 and 1, and we will convert in yes or no to see that outcome. So let's go and check this. Here we go. Our model is giving this yes. If we provide the data for this customer, our model is predicting yes, we can offer the credit card. This is the lead for our credit card offer. And yeah, based on this deployment, you can see I have already given this information you can use for deploying a model. For deploying a model, you need to create an environment for deployment, and uh, you can deploy this model in different web servers and with different cloud services. Some people use AWS as a cloud service. Some people use Azure cloud service, Google Studio cloud service. So there are many cloud services are there. So you can use the same kind of code to deploy the model. But before deploying the model, you have to create the deployment environment. And you can also use the API to insert the input data and the new data to get the output. So using different API interfaces, you can build like Flask, Fast API, and so many API interfaces are there. Using those, you can just insert the data and get the outputs. So now the project has done, and hope you enjoy this live session with me. And in the next session, we will do another end-to-end data science project together and learn more about the data science. Thank you so much for your time.